Hey everybody, this is Mr. Longo, and in this video we are going to cover exponential and logarithmic models. And we're going to need our graphing calculator for this so you can learn how to use your calculator to take some data and make a model. Okay? So this data represents the amount of ethanol that is produced in the US, and this is in billions of gallons. And T is going to represent the year from 2000 on, and then we have G for gallons. And what we're going to do is use our graphing calculator to do this, okay? So this is not going to surprise you because we've done this for linear models, quadratic models, and you can do it for exponential models. What you need to do is add your T into L1 and G into L2, just like we've done in the past. And again, we've done linear regressions, we've done quadratic regressions. Well, your calculator can also do exponential and log regressions as well. So to do that, it's the same thing, L1, L2, but then when you go to Stat and slide over to Calc, you want to scroll down until you get to exponential regression, because that's what we're looking for in this particular problem. It says build an exponential model. Well, if you look at 9 and 10, you have a log regression and you have an exponential regression. So in this case, we want the exponential regression. If we wanted the log regression, you would just go to number 9 instead. And same thing, it's going to ask you for L1, L2. You do not have to store this in Y if you don't want to, because we can just use it later by just plugging in some numbers, or you can store it into Y1 if you want to. We do not need a frequency list, so you can leave those two blank. We're going to go to calculate, and there we have it. We have our 1.439 for our A value and 1.244 for the B value. Okay, so we're not going to need this calculator anymore, so bye-bye. So all we have to do now is write that. So in this case, since we're using G and T, we're going to say that G is equal to the 1.439 times 1.244 raised to the T power. Okay, so that is the exponential model. Now, every now and then it's asked that you manipulate a function, and we're going to express this one in a different form. And we'll talk about why in a second. So what it wants is it just wants you to change it to G of T is equal to G sub 0, which means initial amount. So we already know the initial amount, okay? We know the initial amount is 1.439 because that's not being raised to anything. And we also have the T value. The only thing we want to do is switch this to an E raised to the K model, because the K model is going to be a percentage of growth. So it'll be easier to just read what this function is talking about. So again, we're going to have G of T is equal to, now we already know what G of O is. What we also have is our T. So what we need to do is express e to the K is equal to, well, e raised to K is equal to 1.244. Okay, so now all you have to do is solve. So if you just take the natural log of both sides here, that's going to cancel out your e, and you're going to have K is equal to the natural log of 1.244, which you can just type in your graphing calculator. And to get that, you're just going to get 0.218. Okay? So now we're just going to go back and we're going to say that G of T is equal to our 1.439 times E raised to the 0.218 T. Okay, now that should remind you a little bit of PERT from Algebra 2 Trig, where it was continuous growth. And it was A is equal to P times E raised to the RT instead of the KT, but K is going to actually do the exact same thing. K is your rate. It's your rate of change. So the meaning of K from that problem is 21.8% increase per year. And that's how much more ethanol is being produced every year. So if we were to use this model to predict the amount of ethanol produced in 2019, all you have to do is substitute in 19, because 19 is the years since 2000, into your equation, and that's it. So we would just take 1.439 times E raised to the 0.218 times 19. Type that in our calculator and we're going to get 90.554 billion gallons. Not gallons. Remember, this is in billions. And yes, if you would have had that sent to Y1 of your graphing calculator, you could have just used the table and scrolled all the way to 19. But it was really simple to just type it in instead. So yeah, that's exponential models. Again, if it asks for a logarithmic model, you would just use the ln regression instead. But that's it for this one. This is Longo, and I'm out. See you, bye.